Hello guys, I am Sanirama John Peter and register number is URT24AI1106. Today I am going to explain machine learning laboratory experiment number 3, simple linear multilinear logistic regression. In this experiment we are going to perform these type of regression, and regression is the term is used to we'll try to find the relation between the variables. The supervised learning task, and the output will be continuous values. And the regression analysis statistical method to model the relation between a target and the predictor variable. The target is said to be different variable, and the predictor is said to be independent variable. We can predict the continuous or real values such as temperature, age, and salary and price. So different variable will be the variable you want to predict is called the different variable. And independent is the variable you are using to predict the other variable's value is called the independent variable. So regression analysis is for predictive modeling technique. It will investigate the relationship between target and the predictors. So here is a two benefits of using regression analysis. And first, we are going to see about linear regression. Linear regression establishes a relation between different variable and one or more independent variable using a best fit straight line, also known as the regression line. So, based on the continuous variables, we will be estimate the real value. So here we establish the relationship between independent and dependent variable by using or fitting a best line. Best fit line is known as regression line and is represented by linear equation y is equal to a star x plus b. Here y is dependent variable, a is u, and x is independent, and b is intercept. So these coefficients are based on the SSE, the sum of square difference of distance between actual and the predicted data. This data points and the regression line. Let's get to the problem of the simple linear regression. Okay. Firstly, I imported the necessary libraries for my simple linear regression, pandas, numpy, matplotlib, and for model selection and for pre-processing and for visualization, I imported Cmon library and regression. So mainly I imported from sklearn dot linear underscore model. I import linear regression and some evaluation metrics for the check my model. First question is to read the CSV file. For reading the CSV file, I imported the pandas library and I use this pandas function read.underscore CSV to read the CSV file, and I use this head of to display or output my first five columns. And uh, next is I'm pre-processing. So I'm just use this df.sql of number to pre-process. If there is any null values, we remove or fill them. And next, I'm going to choose the dependent and independent variable. So this kilometer I choose as independent variable and price as the dependent variable because we want to, I want to predict price based on the kilometers the car has living. And next is I'm going to find the B naught and B1. The B naught is intercept and B1 is slope. Okay, we have seen A and B. So here I have fusion B naught and B1. So the slope tell us how much the price decreases for every 1 kilometer price. So I have got my intercept and slope. And next one is we will be calculate the SSE. SSE is sum of square difference between the actual and predicted values. So the formula is summation of y minus y predicted whole the whole square. So it measures the total prediction error. So here it is SSE. And next one is RMSE. The RMSE is the square root of SSE divided by number of observations. So YI observations. So it tells us the average predicted error. Lower RMSE score we will be having a better square, better fit. And next is R square. R square tells us the how well the model explains the data. So R square is 0.6 means its percentage of price variation is explained by kilometer. So higher R square value means better fit. To visualize the plot or to plot the regression line, I use this blue dot. Blue dot represent the actual data and the regression line represent the predicted regression values. Like this line shows the variation between kilometer and the price. So this trend between the kilometer and price. So next is I'm going to predict the value. For how much kilometer, what will be the predicted value? So for example, I've given 50,000 kilometer. The predicted price for 50,000 kilometer is 14,998. So this is a simple regression one. And let's go to multiple regression. So in multiple regression, it's also called MLR, multiple linear regression. So here we will be it's a statistical technique, and we will be predicting the outcome of a response variable. So we will be using several explanatory variables to predict the output of the response variable. The goal of the multiple linear regression is to model the linear relationship between explanatory variable and the response variable. So it is based on the independent variable. It is not too highly correlated with each other, and the Y observation was observed independently and randomly from the population. The residual should be normally distributed with mean of zero and variance. So it is used to model the relationship between two or more feature and response by fitting a linear equation to observe data. The steps to be performed in multiple linear regression is almost similar to the simple linear regression, but the difference lies in the evolution, because we can use it to find that which factor has the highest impact on the printed output, and we can change the factors on that, and we can link the variables to each other. Let's see the code, the questions which ma'am gave. Uh, Multiple year regression. First thing for the necessary libraries, pandas, numpy, and from SQL and linear underscore for linear regression and evolution metrics, and matplotlib for visualization. And I rate my CSQL using this pandas function, p.read underscore CSV, and I shall check that it's in the pre-process technique. I use this df dot instead of sum of. So here we can handle them if they necessary, because we have to remove the null values or unnecessary values in data. And after pre-processing, after dropping this pre-processing, I'm just choosing my independent and dependent variable. We can choose more than one independent variable, the multiple independent variable. So I choose kilometer, age, and HP. Here I also use the current result. No. So I'm importing, I selected three independent variable and price as a different variable, because these are our independent variables. So x1, x2, x like the beginning, and y is our different variable. So from scalar.import_underscore model, I'm importing linear regression. So I'm going to find the intercept and coefficient. So B naught here is the intercept, and B1, B2, B3 are the coefficients. So for each coefficient, it shows how much the price changes when these factors increase by 1 unit. So keeping other variables constant. So here I got intercept as -2 and 88.1 and independent variable coefficients, the future scale and the coefficients. So next one is I'm going to predict the Y. So Y prediction, I'm going to use this model.predictor OAS. So after training the data set, we'll be using this model.predictor to get predicted prices. And next one is I'm going to calculate the SSD, sum of square difference, square error between actual ticket value. So I calculated this. So I've got SSC and also the RMSE values here. I calculated the same one, RMSE. So this RMSE is the square root of the mean square error. It tells us the average of the predicted error. So lower MSE will be the better model. So I got 7 of the lower. So we will be having a better model. And next one is this R square is the how well the model explains the variation of this. For example, if my R square is 0.89, so the 89% of the price variation is explained by the kilometer, age, and HP. So the higher R square means our indicates better performance. So I got 0.89. So we have better performance, and I'm going to predict the new. So for finally, I gave 50,000 kilometer, five the 5 years, and HP is 110. The predicted price for this is the -56.5. So the model predicts the estimated car price using the multiple linear regression. I got minus. Check how can do it. Okay, let's go to next one. That is logistic regression. Logistic regression, the classification algorithm is used for the target variables of the categorical nature. So for numerical data or numerical nature, we'll be using simple linear and multilinear regression. For categorical nature, we'll be using this logistic regression. So the main objective of this LR is to determine relationship between futures and probability of particular outcome. So for example, when you need to predict whether a student passes or fails an exam, given the number of hours spent studying a such future. The target variable comprises two values, past. So performance metric will be using as root mean square error, R squared or coefficient of determination, a mean absolute error, MSE and all. So we have given some questions. Let's see the questions. Logistic regression. Stick regression. So in logistic regression, I import the necessary libraries, pandas, numpy, matplotlib, and standard scalar for pre-processing. I just read the CS file using this in pandas function, and I printed the first five columns, and I pre-process using this df.install of numoff, and I'm dropped and I've filled this one using df.fillNA to fill the numerical values with the mean and encode categorical variables. So I use this dummy variable to encode, and I'm going to uh, like binarize the target variable. So for binarizing, I'm using this kind of code. And next one is we are going to select independent and dependent variable. So before selecting, we have to check if there are categorical variables, we convert them into numerical variables. So using this encoding techniques like one. And I'm going to select the independent variable. Logistic regression is used for classification problem. So we convert one as the expensive car and zero as the cheap car. So independent variables have users, kilometer, age, and HP and price. Another class. This zero. Zero means cheap car, one means expensive car. And next one is regression and regression. This future scaling. I will scale my. It is very important step to scale because I'm going to transform a zero as a expensive or one as cheap, and I'm going to initialize the parameters. So for that, yes, we're going to give this linear line equation. So this is similar to the linear equation regression. Z is equal to P naught plus B1 x1 plus B2 x2 plus C3. So this, I mean, inserting the parameters for sigmoid function. So sigmoid function is then we apply the sigmoid function because the sigmoid convert the output into probability difference between 0, 1, 1. The sigmoid of x is equal to 1 by 1 plus e to the power of minus z. And next one is cost function and gradient descendant. So we use log as the cost function, log loss as a cost function. Plus j is equal to minus 1 by m of summation of y log h plus 1 minus y log of 1 minus h. So this gradient descendant will update the weights of minimize this cost. As iteration increases, cost decreases. And as a sub-service, we will be plotting the iterations and cost. So we plot iterations of x-axis and the cost on y-axis. This graph should show a decreasing curve. It is a decreasing curve. So, and then this calculation accuracy. So, after training, I have to check the accuracy of my data. So, I use this converted probability. So, that I have checked this. So, the accuracy is 100%. And for I'm going to print the new value. So, I gave kilometers with those ages 5 years and HP is movement. And my predicted car, this one is it is a expensive car. So, its value, the price is high. So, this experiment, I have explained simple linear, multilinear, and logistic regression. So we will be using different metrics for each regression lines. So I hope you understand this all. Thank you.